Welcome to The Explainer. Today, we're doing something really cool. We're going to explore how something as simple as, well, sharing your lunch can actually unlock some of the most fundamental concepts in all of mathematics. We're looking at a fantastic chapter called Fair Share. And as you'll see, these highly relatable, everyday situations subtly teach incredibly complex ideas, like fractions.
Okay, let's dive right into this. Have you ever argued over the bigger piece of a chocolate bar? I mean, think back to being a kid for a second. You're splitting a treat with a friend or maybe a sibling, and suddenly you are both eagle-eyed, measuring every single millimeter just to make absolutely sure nobody gets shortchanged. It's a highly relatable, incredibly emotional reality of sharing, right? But what you probably didn't realize at the time is that in those moments of demanding perfect fairness, you were actually doing math.
That brings us to our first core concept. Section 1, what is a fair share? Well, let's take a look at a specific lunch break scenario from our source material that perfectly captures this whole childhood experience.
So here are our main characters, Shabnam and Mukta. They're just hanging out, enjoying their school lunch break, and as you can see, they have a chocolate bar and a paratha to share. But we have a problem. They are currently locked in negotiations over a fair share because the distribution of this lunch feels completely unequal. I mean, one is holding a large whole paratha, and the other has a giant chocolate bar. Figuring out how to divide them fairly, it's causing a little bit of tension.
And here is the exact moment the conflict bubbles over. The text reads, "It is not fair. You gave me a bigger part. These are not equal. Let's divide it equally." This universal demand for fairness, this dramatic little moment on the playground, is actually the absolute perfect launchpad for mathematical problem solving. They aren't just arguing here, they're literally setting up a geometry problem.
We all know we want things to be equal, which naturally leads us to Section 2, finding the perfect half. So how can we actually definitely prove that two pieces are exactly equal? Let's see what Shabnam and Mukta do.
And this brilliantly illustrates the intuitive genius of kids. Instead of breaking out a ruler or some complicated measuring tool, Shabnam simply takes the paratha and folds it directly over itself. It's so clever. It's a brilliant physical geometric proof happening right there on the lunch bench.
Let's quickly break down exactly what she's doing here. Step 1, you take the whole object. Step 2, you fold it completely over itself. And step 3, you check if the edges match exactly to ensure symmetry. It's super simple, yet really profound. This tactile, hands-on strategy naturally builds a young learner's intuition for symmetry and equal division, way before they ever see a scary mathematical formula on a chalkboard.
So, the crucial point is, what happens next in the learning process? The textbook includes a very specific, fascinating pedagogical note for teachers. It says we must ground this definition simply as 1/2, representing a perfectly equal division of a whole. We have to teach this intuitively first, actively avoiding abstract, confusing terms like 1 out of 2 at this stage. By focusing purely on the physical action, like the folded paratha, the concept of half becomes concrete and completely understood.
Now that we've mastered dividing a single physical object, it's time to level up. Section 3, half and double with marbles. We're moving from dividing one solid thing, like a flatbread, to dividing discrete numbers.
Things speed up a bit here. The children are no longer splitting a lunch. They've transitioned to a rapid-fire game using separate, discrete quantities. They're challenging each other, sorting out groups of marbles right there on the floor. "I got 4 marbles," one says. "I got 12 marbles," says the other. They're just rapidly throwing out numbers, which literally forces the brain to calculate equal shares of a scattered, messy group rather than a neat, solid shape. Now, what's really interesting about this slide is how this table perfectly maps out an incredible discovery for a young learner, the inverse relationship between halves and doubles. If you look at column 1, 4 is half of 8, 5 is half of 10, 6 is half of 12. But look at column 2. It completely reverses. 8 is double of 4, 10 is double of 5, 12 is double of 6. They're learning that halving and doubling are essentially just two sides of the exact same mathematical coin.
And the textbook uses this exact relationship to set up a fantastic little puzzle. Listen to this math riddle straight from the text. I have less than the double of 4 marbles. I have more than the half of 10 marbles. Go ahead, try to solve it with me. It's kind of like a mathematical mystery clue, where you actually have to use your new tools of halving and doubling to crack the case.
Notice the girl here, deep in thought, using pure deduction. Let's combine our concepts to help her out. What is the double of 4? Well, that's 8, so she has less than 8 marbles. What is half of 10? That's 5. So she has more than 5 marbles. Okay, more than 5, but less than 8. The answer absolutely has to be either 6 or 7 marbles. By combining halving and doubling, the kids arrive at the solution completely intuitively. No equations needed.
All right, we've conquered the half, and we've conquered discrete groups. Now let's introduce Section 4, introducing the quarter. We're officially expanding our sharing circle from 2 shares all the way up to 4.
Let's move to our next scenario and see how this builds. The textbook poses a new, slightly more complex challenge for us. What happens when we need to share a chicky, that delicious, brittle, sweet snack, equally among 4 people instead of just 2? Our simple paratha folding trick needs a bit of an upgrade. Which brings us to a brand new definition, a quarter. The text states, when a whole is shared equally among 4 people, each share is called a quarter. But notice the really clever instruction the textbook provides for the teacher right here. A quarter can also be beautifully and simply visualized as a half of a half. You fold it once to get 2 equal shares, and you just fold those halves again. It's brilliant. It links the brand new knowledge of a quarter directly back to that physical intuition they've already built with halves.
To wrap up this chapter, the textbook leaves students with a hands-on fraction puzzle using cutout shapes, and I want to leave you with the very same thought. How many pieces did you use to make one whole? Superimpose the pieces to see that they are exactly the same. It's such a powerful concluding thought, isn't it? We spent so much time breaking things apart to ensure a fair share, but ultimately all these fractions, all these halves and quarters, snap right back together to form the complete world around us. So next time you share a meal, ask yourself, how many equal pieces are making up your whole? Thanks for joining me on this explainer, and keep exploring.